Hi, I'm Alan Downey. I teach at Olin College, which is an undergraduate engineering college near Boston. I'm going to tell you about a project I'm working on called Bite-Sized Bayes. For about a decade, I've been developing a curriculum for teaching Bayesian statistics to undergraduates. And for about a decade, most people teaching statistics classes have said no. One of the barriers is the perception that it's too hard, especially for students with little or no calculus. And that might be true if you teach it mathematically, but it's not true if you teach it computationally. This is what a Bayesian update looks like in code. It's really simple. The key idea is to use discrete distributions and discrete approximations of continuous distributions. Then all the integrals go away, and you can use for loops, or in this example, array operations. That's the idea behind ThinkBayes, which you can get from thinkbayes.com. This project has had some success with professionals and graduate students, but it hasn't had much effect on undergraduate education. Which brings me to the second barrier. There is no room to add anything to the curriculum unless you take something out, and no one is willing to take anything out. To which I say, fine. And that's what got me started on Bite-Sized Bayes. If you didn't already notice the URL on the right side of the slides, you can use that to get to the current draft. The idea of Bite-Sized Bayes is the subtitle of this talk, Jupyter Notebooks for adding just enough Bayes to your classes. So for example, if you're already teaching conditional probability, you could use the first notebook, which introduces conditional probability using the Linda the banker problem, which is an example of the conjunction fallacy. It uses data from the General Social Survey, and you can compute things like the probability that Linda is a liberal Democrat, given that she is a female banker. As another example, if you are already teaching Bayes' theorem, you could use this notebook, which is about interpreting medical tests. That has always been an important topic, but even more relevant now. And here's the key. Once you've done those two topics, you have everything you need to do Bayesian statistics, like estimating proportions. So this notebook solves the Euro problem, which I got from David Mackay's book. It uses two different prior distributions, and you can see that the posterior distributions converge. And from there, it's just one more step to solving real problems, like Bayesian A/B testing, using something like the Bayesian Bandit strategy. And by the way, all of these notebooks run in Colab, so students don't have to install anything. It's really one click and you are running the notebook in a browser. So here's the deal. You don't have to create a new class. You don't have to blow up existing classes. You can replace small parts, and you can replace as many as you want. If you are feeling brave, I also think a lot of introductory statistics topics are highly compressible. In particular, we could spend a lot less time on classical statistical inference. That's another talk, but if you follow that link, if you're interested, you can see what I had to say. So that's it. Let's teach Bayesian statistics to undergraduates. What do you say? If you want to talk to me about any of this, here are all the ways to reach me. And there's the link for Bite-Sized Bayes one more time. Thank you.